The final thing we want to do with our polynomial functions in analyzing them is to allow the calculator to give us some information about it as well. So we're going to discuss how to analyze the graph of a polynomial function using our graphing calculator. Now there are some steps that we're going to go through, and this is a summarization of the 8 steps that we're going to use. So let's just jump right on in, get your calculators out, and let's work on this problem right here, example number 4. So we want to analyze this polynomial function. The first thing we want to do, although we're letting our calculator give us the information about the function, eventually we're going to end up kind of sketching the graph for ourselves. So we're going to get some key information using the calculator and then finally graph it ourselves. So if I wanted to determine what the end behavior of this polynomial function was, or what degree polynomial am I looking at, I'm going to start by saying, well, I have x squared times an x to the first power times an x squared to the first power. So that really is a 2, 4, 5, gives me a 5th degree polynomial, meaning that I have a vision already that this is going to go off in opposite directions in its end behavior. Let's go see if we're right. I want you to get your graphing calculator out, and I want you to put this function into the y equals. Okay, so I already have that entered in here. It's x squared times x minus 2 times x squared plus 3. While I'm on this screen, I also wanted to put in another equation for the to graph a line along the x-axis. So I want to put in there y2 is equal to 0. And I want you to adjust your window. Let's just adjust it to the negative and positive 3 for the min and max of x, negative 10 and 5 for the min and max of y. Okay, so this is the window that I am using. The graph of this function looks like this. The blue line is the polynomial function we're investigating, and the red line is that additional line I wanted you to put on the graph. Now the reason I want you to do that is because the next chore on my things to do for analyzing this is to locate both the x and the y intercepts using the graphing calculator. One of the ways, and there's several different ways you can do this, but I tend to go ahead and use the y equals 0 line as an intersection between these two functions we're looking at, between my blue and my red lines. So I can quickly take second trace, find the intersection, which is choice number 5. I want to find the intersection between the blue line, and let me arrow over. I want to be on the other side of that curve because I'm looking at this intersection right here. So I want to be here on the blue line. I want the intersection between the blue line and the red line, and I don't have a guess. That's what it's going to tell me, and it tells me, I don't know if you can see it, but it does tell me that they are intersecting at x is equal to 2, y is equal to 0. Now I can also see that I have an intersection here at the origin. So I can check that by putting in a value. So if I were to say, okay, I want to just make sure, I could use my table as one of the ways to do it, or I can do second trace value. So if I put in, now that wasn't what I wanted. Let's try again. Second trace number 1. There we go. This is what I'm looking for. The calculator is waiting for me to input some value for x. Well, I think that when x is 0, y is going to be 0, but let's just make sure. So if I put 0 in for x, sure enough, that's the actual location of my intersection for the y-intercept. So I have found both of those intersections as well. The next thing that we are being asked to do, and you will be asked to do this on your homework, is to use the table function to find a few more points. Let's say I wanted to know a few more points along my graph happening here at this curve, and maybe I want to know a few more points happening on either side of the x-intercept over here. Okay, so I can use the table function to find these points rather quickly. You must first make sure that the table is set to ask. So we're going to go to Second, Window, and your independent variable, that's the x variable, needs to be set to ask. So if it's not, you're going to arrow down, arrow over till it's highlighted, you click enter, and now it is set to ask. So when I go to the table function, which is second graph, and let me clear out what I have in here, or delete what I have in here maybe. If I wanted to know some more points on that graph that we were looking at, remember I had an x-intercept at 2. So let's say I want to know what's happening at when x is 1. It gives me the y value when x is 1. Let's say I want to know what happens when x is 3. It gives me back the y value when x is 3. So whatever value you put in for x, it gives you back the corresponding y value for the ordered pair on that function. And you might be asked to find that in the homework. So it's using the table function, but you must first set it to ask. The next thing on our agenda is to, once we have our graph, find out what these turning points are. Well, we already know what one of the turning points is because this up here is a max, but it's also an intersection. So we have a max occurring here at the peak of this curve. We have a min occurring at the valley or the bottoming out of this curve. So we're going to use those properties, the max and the min, to find the turning point, the actual turning point of my function. So we go back to second, trace, find the min this time, and I have to be in the right area. I've got to be on the right section of my curve. So this is the curve I'm looking at. So I've got a left hand bound over here. I'm going to arrow over to the other side of where I think the minimum is going to be at. So I have a right hand side of over on this side. I don't know what the guess is. And here it gave me what the minimum is. So we're going to take this and I'm going to copy it over here to the notes. Okay, so here is my graph. You can see here that this is my min over here. My min is occurring at, let's draw it on here. That would be positive 1.4, 1.5, and negative 5.9. And we had, that was down here, we have another turning point occurring here at 0, 0. And we could sketch this by hand if we wanted. I just pulled the graph on here. Now let's talk about the domain and the range. The domain of this function would be all real numbers, and the range of this function is all real numbers as well. So we have a domain and a range of all real numbers, and how about increasing and decreasing? So we know that my function is, remember, increasing and decreasing says as x increases, what happens to y? So where is my function as x is increasing? Where is my y values increasing? That's occurring here from negative infinity to 0. And then it's also occurring here from 1.5 to infinity. In between there, my y values are going down, and that's from 0 down to 1.5. So we'll just sum that up over here. So we are increasing from negative infinity to 0, and from 1.5 to infinity, and we are decreasing from 0 to 1.5. And that's how we're going to use our calculator to be able to analyze a polynomial. Here's one more example for you to practice on before you go. Go ahead and try this on your own and check back and see if you get the answers right. Okay, so if you put this function into your calculator, make sure that when you are entering this term here, the square root of 5, that you arrow over so that your x variable doesn't end up underneath the radical sign. So just looking at the polynomial, we can see that this is a 4th degree polynomial. I can graph it on my calculator. I can see that yes, it is a 4th degree or an even powered polynomial. And using the intersection tool along with my horizontal axis right here or horizontal line, I can find both x-intercepts, and then using the second calc value function, I can find the y-intercept. So I have all three of those intercepts located here on this graph. The next thing that I want to do is I want to use the calculator to find the max and the min for the turning points. Now this function only had one turning point, one place where it actually changed from a negative value to a positive value. So this was a min, and I used the calculator to find that. I got it at these ordered pairs here, negative 0.42 and negative 4.64. So I could sketch the graph using the turning points, using the x-intercepts, perhaps a y-intercept, as well as the end behavior to get an understanding of what this looks like. As far as the domain and the range go, now the domain is all real numbers, but the range for this function is from negative 4.64, the lowest y value possible, up to positive infinity. That's the range. And then I have the increasing and decreasing listed here as well. Remember, increasing is when x is increasing, where is y increasing, and that is in this section over here. We state that based on the x value, so it is increasing from negative 0.42 to infinity. And then the function is decreasing, the y values are decreasing from negative infinity up to negative 0.42. So that's how we can use our graphing calculator to analyze a polynomial function.